Pluto, large, distant member of the solar system that formerly was regarded as the outermost and smallest planet. It also was considered the most recently discovered planet, having been found in 1930. In August 2006, the International Astronomical Union, the organization charged by the scientific community with classifying astronomical objects, voted to remove Pluto from the list of planets and give it the new classification of dwarf planet. The change reflects astronomers' realization that Pluto is a large member of the Kuiper belt, a collection of debris of ice and rock left over from the formation of the solar system and now revolving around the Sun beyond Neptune's orbit. Pluto is not visible in the night sky to the unaided eye. Its largest moon, Charon, is close enough in size to Pluto that it has become common to refer to the two bodies as a double system. Pluto is designated by the symbol. Pluto is named for the god of the underworld in Roman mythology. The Greek equivalent is Hades. It is so distant that the sun's light, which travels about 300,000 kilometers per second, takes more than 5 hours to reach it. An observer standing on Pluto's surface would see the sun as an extremely bright star in the dark sky, providing Pluto on average 1/1600th of the amount of sunlight that reaches Earth. Pluto's surface temperature, therefore, is so cold that common gases, such as nitrogen and carbon monoxide, exist there as ices. Because of Pluto's remoteness and small size, even the best telescopes on Earth and in Earth orbit could resolve little detail of its surface. Indeed, for decades, such basic information as its radius and mass had been difficult to determine. It was not until Pluto was visited by the U.S. spacecraft New Horizons, which flew by Pluto, and its satellite Charon in July 2015, that many key questions about it and its environs were answered. Pluto's mean distance from the Sun, about 5.9 billion kilometers, gives it an orbit larger than that of the outermost planet, Neptune. 1 astronomical unit is the average distance from Earth to the Sun, about 150 million kilometers. Its orbit, compared with those of the planets, is atypical in several ways. It is more elongated or eccentric than any of the planetary orbits, and more inclined to the ecliptic, the plane of Earth's orbit, near which the orbits of most of the planets lie. In traveling its eccentric path around the Sun, Pluto varies in distance from 29.7 AU at its closest point to the Sun to 49.5 AU at its farthest point. Because Neptune orbits in a nearly circular path, Pluto is for a small part of each revolution actually closer to the Sun than is Neptune. Nevertheless, the two bodies will never collide because Pluto is locked in a stabilizing 3-2 resonance with Neptune. That is, it completes 2 orbits around the Sun in exactly the time it takes Neptune to complete 3. This gravitational interaction affects their orbits such that they can never pass closer than about 17 AU. The last time Pluto reached perihelion occurred in 1989. For about 10 years before that time, and again afterward, Neptune was more distant than Pluto from the Sun. Observations from Earth have revealed that Pluto's brightness varies with a period of 6.3873 Earth days, which is now well established as its rotation period. Of the planets, only Mercury, with a rotation period of almost 59 days, and Venus, with 243 days, turn more slowly. Pluto's axis of rotation is tilted at an angle of 120 degrees from the perpendicular to the plane of its orbit, so that its north pole actually points 30 degrees below the plane. By convention, above the plane is taken to mean in the direction of Earth's and the Sun's north poles, below in the opposite direction. For comparison, Earth's north polar axis is tilted 23.5 degrees away from the perpendicular, above its orbital plane. Pluto thus rotates nearly on its side in a retrograde direction. Compared with the planets, Pluto is also anomalous in its physical characteristics. Pluto has a radius less than half that of Mercury. It is only about 2/3 the size of Earth's moon. Next to the outer planets, the giants Jupiter, Saturn, Uranus, and Neptune, it is strikingly tiny. When these characteristics are combined with what is known about its density and composition, Pluto appears to have more in common with the large icy moons of the outer planets than with any of the planets themselves. Its closest twin is Neptune's moon Triton, which suggests a similar origin for these two bodies. Although the detection of methane ice on Pluto's surface in the 1970s gave scientists confidence that the body had an atmosphere, direct observation of it had to wait until the next decade. Discovery of its atmosphere was made in 1988 when Pluto passed in front of, occulted, a star as observed from Earth. The star's light gradually dimmed just before it disappeared behind Pluto, demonstrating the presence of a thin, greatly distended atmosphere. Because Pluto's atmosphere must consist of vapors in equilibrium with their ices, small changes in temperature should have a large effect on the amount of gas in the atmosphere. During the years surrounding Pluto's perihelion in 1989, when Pluto was slightly less cold than average, more of its frozen gases vaporized. The atmosphere was then at or near its thickest, making it a favorable time to study the body. Astronomers in the year 2000 estimated a surface pressure in the range of a few to several tens of microbars. 1 microbar is 1/1,000,000th of sea level pressure on Earth. At aphelion, when Pluto is receiving the least sunlight, its atmosphere may not be detectable at all. Observations made during occultations showed that nitrogen was the primary gas in the Plutonian atmosphere, which also contained small amounts of methane, carbon monoxide, and hydrogen cyanide. Nitrogen is also the main constituent of the atmospheres of both Triton and Saturn's largest satellite, Titan, as well as of Earth. During its flyby, New Horizons determined the surface pressure to be 10 microbars and found acetylene, ethylene, and ethane in the atmosphere. The temperature near the surface is 45 K. Haze layers are seen up to an altitude of 200 kilometers. The upper atmosphere is quite extended, going up to 1,800 kilometers from the surface, and quite cold, which keeps nitrogen from escaping into space. New Horizons observed only one hemisphere of Pluto. That hemisphere is dominated by Tombaugh Regio, a white heart-shaped plain. The western half of Tombaugh Regio is Sputnik Planitia, a smooth plain of nitrogen ice without impact craters. The lack of craters shows that Sputnik Planitia is a very young feature, and thus that Pluto likely has some geologic activity. Tombaugh Regio is surrounded by less smooth regions that contain some mountain ranges. These mountains are made of water ice, which are likely floating in the surrounding nitrogen ice. Higher northern latitudes are covered in darker plains. To the west of Tombaugh, Regio is the darkest region on Pluto, originally nicknamed the Whale for its shape and later dubbed Cthulhu Regio. This region has a varied topography with plains, scarps, mountains, and craters. This region's dark color arises from organic compounds called tholins. Pluto's average reflectivity, or albedo, is 0.72, compared with 0.1 for the Moon and 0.8 for Triton. However, this average albedo encompasses a wide range of reflectivities, with Cthulhu Regio having a reflectivity of 0.1 to 0.2, and Tombaugh Regio having a reflectivity from 0.8 to 1. The first crude infrared spectroscopic measurements, made in 1976, revealed the presence of solid methane on Pluto's surface. Using new ground-based instrumentation available in the early 1990s, observers discovered ices of water, carbon monoxide, and molecular nitrogen. Although nitrogen's spectral signature is intrinsically very weak, it is now clear that this substance must be the dominant surface constituent. The methane is present both as patches of pure methane ice and as a frozen solution of methane in the nitrogen ice. Pluto has a density of 1.85 grams per cubic cm, and Charon has a density of 1.7 grams per cubic cm. These values suggest that both bodies are composed of a significant fraction of materials, such as silicate rock and organic compounds, denser than water ice, which has a density of 1 gram per cubic cm. Charon's lower density may have arisen from its being more porous or having a lower fraction of rock. Pluto, like the icy moons of Jupiter and Saturn, likely has an inner rocky core surrounded by a thick mantle of water ice. The frozen nitrogen, carbon monoxide, and methane observed on its surface are in the form of a relatively thin layer, similar to the layer of water on Earth's surface. Sputnik Planitia is a deep basin that may have formed as a result of an impact. It is located on Pluto's tidal axis. That is, it is on the opposite side of the dwarf planet from Charon. Sputnik Planitia's location requires that there be extra mass underneath it, and this extra mass may be from a subsurface ocean above the rocky core and below the water ice mantle. Pluto possesses 5 known moons. Charon, by far the largest, is fully half the size of Pluto. It revolves around Pluto. More accurately, the two bodies revolve around a common center of mass at a distance of about 19,640 kilometers, equal to about 8 Pluto diameters. By contrast, Earth's moon is a little more than 1/4 the size of Earth and is separated from the latter by about 30 Earth diameters. Charon's period of revolution is exactly equal to the rotation period of Pluto itself. In other words, Charon is in synchronous orbit around Pluto. As a result, Charon is visible from only one hemisphere of Pluto. It remains above the same location on Pluto's surface, never rising or setting, just as do communications satellites in geostationary orbits over Earth. See spaceflight, Earth orbit. In addition, as with most moons in the solar system, Charon is in a state of synchronous rotation. That is, it always presents the same face to Pluto.